All right, well, hello again. We are finally on to part 7 of the sequences video and videos, and this is the final part. All right, so we're going to cover the last 3 pages in our packet. So you should be on page 20 of the packet. All right, so what we're going to talk about today is something called summation notation or sigma notation. Okay, this is the sigma symbol. Some of you may have seen this. This is one of the letters of the Greek alphabet. Okay, this means sigma. Okay, now if you notice, see how this says summation? You'll see the word sum. Sum means we're going to add. So this is how it works. We want to add together, right? We want to take this formula. See it says formula for the terms. We want to take this formula right here, 4n. And we want to take the sum. We want to add together all of the terms from when n equals 1 all the way up to when n equals 6 for this expression 4n. Now, what does that even mean? Okay, let me explain what that means. We're going to take the number on the bottom. This is our starting value. See how it says first value of n? We're going to start at this number, 1, and we're going to plug it in for n. So 4 times 1. That's what we wrote right here. Okay, then since we want to take the sum, we're going to add to that. Now let's plug in the next consecutive integer after 1, which would be 2. So we're going to do 4 times 2. See, there we have it, 4 times 2. And then we're going to add to that. Well, the next consecutive integer after 2 would be 3. So we're going to have 4 times 3. And you're going to keep going, 4 times 4, 4 times 5. How do we know when to stop? Well, we're going to stop after we plug in, or once we plug in, the number on top of this sigma symbol right here. So once we plug in a 6, so 4 times 6. And then what we want to do is we want to add all these together. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12, and so on. 4 times 4, 4 times 5, and 4 times 6. And we're going to add all these together, and that will give us 68. Okay? So 68 is the sum of 4n from when n equals 1 to when n equals 6. Okay, let's try it with this one down here. I'm just going to move this up a little to give myself a little more room. Okay, so remember, what we're going to do is we're going to start by taking the number on the bottom of the sigma symbol, and we're going to plug it in for the variable. This time we're using k instead of n. So we're going to write 2 times 3 plus 1. Okay, so this is equal to 2 times 3 plus 1. Okay, I'm just going to group that together in a parenthesis. Now we want to add to that what we get when we plug in the next consecutive integer after 3. So the next consecutive integer after 3 would be 4. So now we're going to replace that k with a 4. So it's going to be 2 times 4 plus 1. I'll just put that in a big parenthesis. So 2 times 4 plus 1. Okay, now we want to add to that. Well, the next consecutive integer after 4 would be 5. So we're going to replace that with a 5. So 2 times 5 plus 1. And then we're actually at our last one because the number on top is a 6. So that's the last value that we're going to substitute the k with. So it'll be 2 times 6 plus 1. All right, and then all we have to do is just figure out what all of this is equal to. All right, so 2 times 3 is 6, and 6 plus 1 is 7. So this is equal to 7. Okay, and then plus 2 times 4 is 8, and 8 plus 1 is 9. 2 times 5 is 10, and 10 plus 1 is 11. And then same thing here. 2 times 6 is 12, and 12 plus 1 is 13. All right, so now if we want to add all these together, this is actually easy to add together because 9 plus 11 is 20, and 7 plus 13 is 20. So 20 plus 20 is 40. If you add all this up, you wind up getting 40. Okay, we're going to do some of these together. I know in some of the other videos I wanted you to try things on your own first, but I do want to talk about some of these together first. Okay, so number 46, Kristen wants to increase her running endurance. According to experts, a gradual mile increase of 10% per week can reduce the risk of injury. So she's increasing what she's running by 10% per week, right? That would be 1 plus the rate. So 1 plus 0.10 would be 1.10, or just 1.1. But I'm just writing this as 0.10 so you could see how it matches up with the 10%. So that would be our R. That's what we're multiplying by to get from one term to the next. Okay, if Kristen runs 8 miles in week 1, so that's telling us that a sub 1 is equal to 8, the first term, right? Which expression can help her find the total number of miles she will run over the course of her 6-week training program? So she's going to be running for a total of 6 weeks. So that's telling us that n equals 6. Now, before we get to these answer choices, I just want to review what we talked about in the 6th video, okay? In the 6th video, we learned the formula for a geometric series. What that means is you want to take the sum of the first n terms for a geometric sequence. And here, this is geometric because we're multiplying by 1.10 to get from one term to the next. So this is the formula that we were using in the last video to find the sum of the first n terms. So if we were to use this formula, we could write s sub 6, so let's write this out, okay, equals a sub 1, which is 8, minus a sub 1, so 8 minus 8, times r, which we set up here as 1.10, to the nth power, so it's to the 6th power, and that would be over 1 minus r, so 1 minus 1.0. Okay, and then we could figure out what this is equal to, but let's look at choice 3 and choice 4. Okay, so this says 8 minus 8 times 1.10 to the 6, which matches up with our numerator, but 1 minus 1.10 is negative 0.10, not 90. So choice 3 doesn't match up. Okay, if we look at choice 4, actually choice 4, the numerator as well as the denominator don't match up at all. So that one doesn't work either. So what we're going to have to do is we're going to have to use our new sigma symbol. Now let's think about how this is going to work. Okay, I kind of wrote a general format of how this is going to work. Basically, if you want to take the sum of the first however many terms, right? We're going to start on the first week and we're going to go until the last week or the last term of what we're looking at. Now in here, this is just the explicit formula for a geometric sequence, right? You want to take the first term and multiply it by r and raise that to the n minus 1 power. But you want to do that for the first week and the second week and the third week, all the way up until the last week that you want to go. So in this example, let's say we would start at week 1 and we would do this for 6 weeks. And in the first week, a sub 1 is equal, she's going to be running 8 miles. And she's going to increase that by 10% per week. So we're going to multiply that by 1.10. And we know within our explicit formula, the exponent here is n minus 1. Okay, so if we look, this actually matches exactly with choice 1. So choice 1 would be our answer. Okay, so 47 is very similar to the one we just talked about. So see if you could do this one on your own. See which answer choice you get. All right, so I went through and organized the information. She wants to increase her laps by 8% per week. So we're going to multiply that by 1 plus 8%, so 1 plus 0.08, which is 1.08. She can currently swim 200 laps, so that's what she's starting off with. So that would be her first term. And she wants to figure out how many laps she could do in total. So let me just point that out. During her 10-week training schedule, so for a number of 10 weeks. Okay, so we have two different choices. We could write it in sigma notation, or we could write it using our geometric series formula. Okay, so I'm going to start with the formula we talked about in the last video. So we're going to see if choice 3 or 4 works first. So we know in that formula it's going to be the sum of the first n terms. So the sum of the first, well here since n is 10, it's going to be the sum of the first 10 terms. And that's going to be equal to the first term, a sub 1, minus a sub 1, so 200 minus 200, times r, which is 1.08, to the nth power, which n is 10. And we put that over 1 minus r, so 1 minus 1.08. Right, so let's see if choice 3 or 4 matches up. Well, choice 3 doesn't match up because they used a 0.08 and we have a 1.08. So that one we can cross off. And then choice 4, the numerator, yeah, looks the same. Oh, but not the denominator. So we can cross off choice 4. Okay, now let's look at choice 1 and choice 2. So if we're going to write it using sigma notation, we're going to start. I'm going to use the variable they do it, n equals 1. And we want to do this for 10 weeks, so 10 is going to go on top. Now, really, all we're doing here is writing our explicit formula, but plugging in our information. So the explicit formula for a geometric sequence is right here. So we're going to plug in this side of the formula after the sigma symbol. So the first term is equal to 200, and then times r, which is 1.08, to the n minus 1 power. And that matches up with choice 1. So choice 1 is our answer. Okay, I think I'm going to do number 48 with you, and then you guys can end off by doing 49 on your own. All right, so Ariana earns $40,200 for her first year. So since that's her first year's salary as the hurdle coach at the University of Syracuse, we could say that A sub 1 is $40,200. Okay, she is told that if she continues uninterrupted employment, she will be guaranteed a 6.25% raise each year. So it's going to go up by 6.25%. So 1 plus the rate, 1 plus 0.0625, right, if we move the decimal place back twice, would be 1.0625. So that's going to be our R. That's what we're multiplying by to get from one term to the next. Okay, so part A. Write a geometric series formula, S sub n, for Ariana's total earnings over n years. Okay, so that formula we've used so many times. I'm sure you guys definitely have that memorized, although you don't have to. It's on the reference sheet. So we can write S sub n. We're leaving it in terms of n, right? Is equal to the first term minus the first term times r to the n power over 1 minus r. So that's all you have to do for this part of the question. Okay, part B, use the formula above. So use this formula to determine, I guess I should say Ariana's total earnings for her first 10 years of working. So here they're telling us that we're going to substitute the n with 10. Okay, and then I guess plug it in your calculator and round to the nearest cent. All right, so we're going to find S sub 10. And you want to show this work on your paper. Don't just plug it in the calculator. You want to show where you're getting your answer from. All right, so we're taking the equation from part A, and wherever we see an n, we're just going to replace it with 10. All right, and then let's just plug this whole thing right here into our calculator and round to the nearest cent, which means 2 decimal places. All right, so when we do that, the sum of her first 10 years on the job, she'll be making $536,130 and to the nearest cent, 21 cents. So this would be the answer to part B. Okay, now part C, write a summation expression. All right, summation means they want us to use this symbol. That can be used to determine her total earnings. And the reason this is used for total is because this takes the sum of the first however many terms, okay, over 10 years. So we're going to be doing this for 10 terms. So we're going to start at n equals 1, her first year, and we're going to go all the way up to 10 years. And we know here we just use our explicit, geometric explicit formula. So A sub n is equal to A sub 1. So we know A sub 1 is 40,200 times R, which is 1.0625. And the explicit formula has an exponent of n minus 1. So this would be our answer here. Now, the reason they had you do this I'm assuming, is because they wanted to see that if we were to figure out what this is equal to, we would hope we get the same exact thing as we did in part B, because these formulas are interchangeable. You can use, one or the other. Now, rather than listing out 10 terms, right? If we plugged in a 1 for n, and then a 2 for n, then 3 for n, all the way up to 10, and add those together, that may take a while. I'm going to actually show you how you can do this in your calculator. Okay, so this is how we do it. Now, if you hit, it's going to be hard to do it on here, but if you hit the math button, and if you scroll all the way down, or it's faster to scroll up, see where it says right here, summation? Okay, I'm going to hit enter on that. Now, I'm just going to follow this. See how it says n equals 1? Instead of using an n, I'm just going to use x. So I'm going to type in x equals 1. Okay, so I have x equals 1. Now, see how here it says 10 on top? I'm just going to put a 10 right up there. So let's replace that with, oh wait, let me scroll up to it. Sorry, I have to keep moving this. Let me scroll up and type that in as 10. Then within these parentheses here, okay, within these parentheses, I just want to type all of this, but I'm going to use an x instead of an n. So I'm going to type, let's see, it says 40,200, and then in parentheses, I'm going to put 1.0625, close up those parentheses, and I'm going to raise that to the, instead of n minus 1, x minus 1 power. Okay, and then I'm just going to hit enter. And when I do, look at this, you'll notice that I get the same value in here as I did up here in part B when we did it by hand. Okay, so these match up. So that's a good way to check and, if you got your formulas correct. All right, so 49 is very similar to what we did in 48. So try this on your own, guys, okay? All right, so at this point, you guys should have tried it on your own. So I'm just going to organize the information here. Okay, so let's see. A sub 1 is equal to 26,750, because that's what she made her first year. R is equal to 1.0475, because it's 1 plus. Since it's increasing by this percent, it's 1 plus this rate. So the rate, if you move the decimal place back twice, would be 0.0475. And when we add that to 1, we get 1.0475. All right, so in part A, they just wanted us to write a geometric series formula. So this is the setup of the formula. And they wanted it over the first n years. So we're leaving these n's, right? We want it in terms of n. And you're just replacing the a sub 1's as well as the r's. So this is the answer for part A. Okay, now in part B, they want us to use that formula to determine her earnings for the first 14 years of working. So here, they're telling us that we're going to do this for 14 terms. So just replace the n's with 14. All right, so here we go. This is what we get when you replace the n's with 14's. And then you're just going to plug this all in your calculator, and it says to round to the nearest cent. Okay, and even if it didn't say what to round to, with money, if it doesn't say what to round to, that's what we always write. Okay, so here, when you plug this in your calculator to the nearest cent, we wind up getting a total of $515,258.84. Okay, and then part B wants us to basically take the same information and write it in summation notation. Okay, so we know that in order to do that, we need to use the sigma symbol. We're going to start at year 1, and we're going to go all the way up to year 14. Okay, now after this, we're just using our explicit formula. We're using the right side of the formula for a geometric series. So a sub 1, we already said, was equal to her first year's salary, which is $26,750. R is 1.0475. And we're going to leave that in terms of n to the n minus 1 power. And the reason we leave it in terms of n is so that we could substitute. If we wanted to do this by hand, we could substitute in 1 for n, and then 2 for n, and then 3 for n, and so on, all the way up to 14 and add all those together. Now, I'm going to do this again in my calculator just to make sure that this formula matches up with the answer I got here. Okay, so what we're going to do is I'm going to plug all of this into my calculator. All right, so to do that, if you remember, I'm going to go down here, I'm going to say hit math, and it's actually faster to scroll up than it is to scroll down, but you want to get to the 0, which says summation, so we could hit enter. Now, since it says down here n equals 1, on my calculator, I'm just going to type in x equals 1. I'm sorry it's hard to see. I have to kind of like lift my iPad a little bit to see what I'm typing on the calculator. And then on the top, since this says 14, I'm going to put a 14 on top there. All right, so let's see. I'm going to make that 14. Okay, now, within these parentheses right here, I'm going to type exactly what I say. Okay, make sure it all goes within those given parentheses. And you should be doing this just to make sure that you know exactly how to type this in and you're getting the same answer that I am. So I'm just typing in exactly what I see. And I'm going to raise that, instead of to the n minus 1 power, I'm going to raise that to the x minus 1 power. And the reason I'm using x is because I had used an x here instead of an n. Okay, so now when we hit enter, awesome, what you'll see is I got the same value here as I did up there. So that means these two formulas, as long as I used all the right values for a sub 1 and r and everything, they match up. All right, and this is the end of the 7th video, the end of the sequence packet.